Okay, in this lesson, we're going to go ahead and we're going to review polynomial operations for students who are in pre-calculus. Okay, so just a review of what a polynomial is. It's the sum or difference of many monomials, and we talked about monomials in a previous lesson. The highest exponent of a polynomial is what we call the degree. So just like standard form of a polynomial looks like this. Okay, and so we have subscripts and we have exponents. So a sub n means like the coefficient of the highest degree variable. So if it's a fifth, the degree is 5, so then you would have the coefficient of it. Okay, a sub 0s are constant, and that's standard form. We usually in standard form, remember, it goes in descending order, greatest degree monomial down to the least degree monomial. Monomials by degree. So these all have specific names. So when we have degree 0, it's called a constant. So that would be something like the expression -3. If it's degree 1, it's called linear. So that would be something like 3x. If it's degree 2, it's called quadratic. Degree 3, cubic. Then we have quartic. Technically, 5th degree is quintic. However, after that, we just say the degree number, and we would say like 6th degree polynomial or something like that. One term, so this is called a monomial. Okay, 2 terms is called a binomial. And 3 wheels on a bike is a tricycle, so 3 terms is a trinomial. And we don't really have many special names after that, so I mean, you could say like quadrinomial, but nobody ever says that because that's goofy. So we just call it a polynomial. Okay, one more thing to add is when we go ahead and we talk about classifying polynomials, we're talking about classifying them when they're in their... When we classify polynomials like this over here, we got to make sure that they're in standard form. So if you have something like this, 5x times 3x, that is not considered degree 1. And that's because if you simplify it, it would give you 15x squared. So just like with our rules of exponents, x to the first times x to the first gives us x squared. If we are looking at a polynomial that is not in standard form and it's being multiplied, we can simply add the degrees of each factor to get our degree of our polynomial. Okay? Okay, some operations. Remember, operations are add, subtract, multiply, divide. Those are our basic operations, and we can do every single one of them when we're talking about polynomials. However, we are not going to do division because we're just really doing a review. So let's go ahead and just pick one. I'm going to pick number 10. You can pick more if you like. One of the things is, remember, we add like terms, we subtract like terms. So if I have 3w squared and I want to subtract a term from the second polynomial, I have to pick one that also is w squared. And 3w squared minus 3w squared is 0w squared. One strategy that many people use is they go ahead and when they're adding and subtracting polynomials is they distribute the subtraction sign. And that way they don't forget about it and they just go ahead and combine. So we're combining those, and they cancel because they're opposites. 2w goes with negative 7w, which makes negative 5w. Negative 6 goes with negative 9. Negative 6 take away 9. Negative 15, and so our expression simplifies to this. Okay, we can also multiply polynomials. A strategy that I use is I use a multiplication box. There are other ways to do it, just like using the distributive property. Just as a caution on problems like number 15 and number 18, remember 4j minus 7k squared means a binomial times a binomial. On number 18, you would do this multiplied by itself, this multiplied by itself, and then multiply them. So that would give you 2 quadratics, as a matter of fact, times quadratics, and it's a lot of work. So we're just going to do a simple one. So let's go ahead and let's look at number 14. So number 14, before I actually do the multiplication, I have to go ahead and I'm going to use the distributive property beforehand. And that's because that's a little bit easier to do than multiplying these type of binomials at this time. So I'm going to do keep this 4t minus 1 times 5t plus 3. And then I'm going to do minus 20t squared plus 18t. Now these two are being multiplied, and this one is just subtraction and addition. So I need to go ahead and I need to take this, and I'm going to multiply them out. So how you can use the multiplication box and minus it up 3 by 2, but this is a 2 by 2, so I'm going to go ahead and I'm going to get rid of that one. I'm going to do 4t minus 1, and you could use FOIL on this way, by the way. But here's how it works. 5 times 4 is 20. T times t is 20 squared. 5t times negative 1 is negative 5t. Then I'm going to go to the second row. 4t times 3 is 12t. And then negative 1 times positive 3 makes negative 3. Then I go ahead and I combine my like terms. So now what I have is, and I'm going to write this over here, I have 20t squared. And then these are like terms. 12 and negative 5 is 7t. And negative 3 minus the 20t squared that was there plus 18t. Okay, now I'm ready to go ahead and combine like terms. So I have 20t squared and negative 22t squared, so they cancel. 70t goes with 18t, which makes 25t. Negative 3 doesn't have anything to go with, so we just write negative 3. So in the end, when we're going on and simplify this, it becomes a 2 terms, so it's called a binomial. Degree is 1, so it's first degree binomial. Okay, let's go ahead and try one more. Let's do number 13. Okay, so number 13 is just a straight multiplication one, so it's 2 terms binomial by 3 terms, which is a trinomial. Okay, now I'm going to go ahead and remember 2x squared times x, 2x cubed, because I add the exponents. 2x squared times negative 3, which is negative 6x squared, and then I keep doing row by column. So this would be 6x squared, negative 18x, negative 7x, and positive 21. Remember, this is just a tool. You don't have to use it, but it does keep everything nice and organized along that diagonal, and it's really helpful when you have to do some big ones. Okay, so we have 2x cubed, negative 6x squared, and 7x squared are going to cancel. Oops, why did that move? Negative 6x squared and 6x squared are going to cancel. And then negative 18x, negative 7x makes negative 25. So here's our answer to number 13. 2x cubed minus 25x plus 21. And that's it. Thanks.